Have you ever stared at a math problem and you feel like you're reading a secret language from a completely different planet, a language of strange symbols and rigid rules that just doesn't connect with your brain? If you do, then you are not alone. For centuries, we thought of math as this cold, logical, and sometimes brutal subject. But what if I told you that math isn't just a subject? It's actually a story. It's quite dramatic, actually. It has millennia spanning full epic full of mystery, practical problem solving, and moments of pure mind bending inventions that seem completely useless until it wasn't useless. I want to unlock this door with you and dive into the secret drama of numbers, uncover why it can be so difficult, and also I'll give you the keys to finally start speaking its language a little bit as well. This is coming from someone who absolutely hated maths once upon a time into now literally absolutely loving maths. Like, my professor was so good at maths. When he was talking about maths and going through the engineering concepts of maths, he spoke as if he was looking at his child, like he was like as if, I don't know how to describe it. He was just like, look at this beautiful graph. And I was like, you know what? I understand what you're saying. That graph looks beautiful. I never would have thought that graph looked beautiful before, but he inspired me to do that. So I love maths now, and that's what we're gonna be talking about. Now, the history of math begins exactly where you expected. It came with survival. We started counting because of tribes once upon a time, when we were like, how many people are in a tribe? How many days until the next full moon? While we didn't know a lot of things, we still wanted to know exactly what amount certain things are, if that makes sense. So they would count on their fingers, they would use stones, they would use literally anything that they could use to count. They would. It was simple and it was very practical as well. Now, as societies grew, so did our mathematical ambition. We used the elegant logic of geometry and arithmetic to engineer marvels. It allowed us to build cities, it allowed us to build your homes, it allowed us to make phones, it allowed us to do literally everything that we do nowadays. It also allowed us to have or construct a vast trade empires. It also allowed us to chart the stars and also construct trade empires. For thousands of years, math was a practical servant built to answer questions about the world we could see and touch. So going back now to the 1500s, Italian mathematicians were in a fierce intellectual battle to solve problems that had stumped the greatest minds of centuries. There is currently the unsolvable math question about the perfect number. And basically, this perfect number is saying that, like, if you were to look at the factors of a number, for example, the number 6, the number 6 has the factors of 1, 2, and 3, and also 6 as well, but we're going to ignore 6 because 6 is its own number. If you add up all the factors, excluding the 6, to each other, and then add up to the number that you're looking at, so 1 plus 2 plus 3 equals 6, that becomes a perfect number. The list of the perfect numbers were 6, 28, 496, and 8,128. Now, it's currently unsolvable because we can't really pinpoint exactly what rule it is that makes them a perfect number and what pattern there is. With this perfect number and all other types of questions out there and different types of equations and things like that, it was what was allowing us to kind of wrestle with the complex equations and the formulas that kept leading them to a place where mathematicians along the years would agree was basically pure fantasy. To find real tangible answers, they first had to calculate something impossible. For example, the square root of a negative number. This number was a paradox. If you put it into your calculator, you will see that the square root of a negative number will always give you an error. This had no place in reality. Again, it just gave you an error. It just doesn't work to square root a negative number. They called these numbers as imaginary, therefore. A fitting name for something that seemed like a mathematical ghost, obviously. For nearly 300 years, the idea remained a beautiful but useless curiosity, a testament to how far mathematicians would go to solve a purely abstract puzzle. Now, here's one of the most incredible wow moments in mathematics, which was literally where, after centuries, the humans faced a new challenge, which is mastering the skies. To design an airplane, you have to understand the impossible complexity patterns of airflow and pressure. Otherwise, your plane could not stay upright. If you don't know what the vortexes do, or what vortexes are created and what the airflow is, when the plane flies through the air, the plane will not be able to stay upright, obviously, because you'll mess up in the calculations and therefore mess up on the design itself. The equations were chaotic, but Scientists discovered that the key to taming this chaos, to perfectly describing the lift that makes flight possible, was actually the imaginary numbers that we created out of pure fantasy hundreds and hundreds years back before this. The imaginary number that was born from a purely intellectual puzzle turned out to be the indispensable tool for conquering the air. It is a stunning reminder that sometimes the most abstract pursuits can lead to the most profound real-world discoveries. When I found out about this, honestly, that blew my mind completely. Because how did we go from something that we literally just made up into actually becoming the perfect exact thing that was needed in the real-world scenario? Like, I just don't understand it. That's the crazy thing that happens when it comes to maths. So if maths is this incredible human story, why does it often feel like a glitch in the matrix? Like, why does it feel so frustrating to actually understand and to actually learn math? Honestly, it just makes me crash out half the time. Like, I'm literally crying on the floor when I'm in the middle of an engineering exam type of thing. So the reason number one is because math is a ladder with no safety net. Learning math feels like climbing a ladder. It's like learning new skills, and every rung is a new skill that rests on the one below it. But if you have a weak rung, then it can snap off and you can fall off. You need to be able to master all the basics before you go to the next one, because math compounds on one another. If you miss one of the more basic fundamental topics, it makes all the other ones a lot more difficult. And that's why it's so difficult to do, because at the same time, we're never really taught on how to actually learn maths. So if we're not taught how to learn maths and you end up missing up on the foundational topics, what do you think is going to happen? Obviously, it's going to make us much more frustrated when we're trying to learn all the complex parts of maths, like differentiation, integration, for example. And just like climbing a ladder, you can't just skip the rung. You have to actually go back and make sure that each one is fine before you can safely climb back up. Now, the second thing is that we are taught to follow the map, not how to actually read the compass. So what often we're taught maths like as if it's a list of instructions on a page. You do this in order to do this in order to do this. But you don't actually understand why we do that. And I'm not gonna lie, most people probably don't even understand why maths is maths. I don't understand why maths is maths. I'm not saying I'm any good at maths. I love maths. I probably am pretty good at maths compared to how I was before, but I'm in no way, shape, or form one of the smartest people in the world to do mathematics. And because of that, it just makes it so we are so used to kind of following the commands like a robot, as compared to understanding the underlying logic behind these mathematical equations or even concepts. And that would be the compass. With this, you can then navigate any new terrain on your own and will understand how any type of maths can actually be pretty simple. Now, reason number three on why maths is difficult is because it is a language without an immersion program. At its heart, mathematics is a language. You can understand English, Spanish, French, whatever language it is in the world, but you will still be connected by maths, because no matter where you are in the world, maths is maths. It's the same thing everywhere in the world. It has nouns, which is your numbers, it has verbs, which is your operations, and it has grammars, which is your rules and theorems. But we are oftenly expected to read complex sentences before we even start off with learning what the vowels are, what consonants are, and what the alphabets even are. It feels abstract because we've been thrown into the deep end without being taught how to actually swim. Now, the good news is anyone can learn how to read this code, and it's not about being a math prodigy or even a math person. It is about having the right strategy. And this is what I've been looking at recently. I don't know why I've been so intrigued about maths in general, but it's literally been like my hyper fixation for the past couple days. I've been watching documentaries, 1.5 hour long documentaries about the history of maths, the unsolvable problem that I was telling you guys before about the perfect number, and looking at different mathematical equations and certain rules and things like that. I have no idea what's going on with me right now, but it's just been super interesting and I just had to share it with you guys. And obviously through all of that, it led me to think about what is going through my mind as I'm walking through it. It made me realize that, firstly, I start to question what is intelligence? Like, what actually makes us be able to think this way, and what makes us be able to understand maths? If intelligence is defined to be the ability of oneself to adapt and learn from experience, then does that mean that if we learn more and experience more, we become more intelligent? And hence, my brain automatically went into thinking, does that mean if I continuously to learn different types of maths and also learning about new concepts in the world, will that make me smarter? And hence, I stumbled upon this rabbit hole of falling into the deep hole about what maths is. And again, yeah, it allowed me to kind of put together this list of how to be good at maths, I would say. And this is coming again from someone who used to fail all of my maths classes and everything into getting, I think my highest grade in university was 93.8% in maths, and that was in engineering mathematics, further engineering mathematics, beating 1,000 students in my university. So I had to mention that because I said that once in TikTok and people were like, oh, it must be because you're doing some easy maths. I don't know why that got to me so much, but it did. And yes, I'm very proud of that, so I will mention that. Okay, so firstly, you want to find your broken rungs. Remember the ladder scenario that we were talking about before? You cannot climb up the steps if you have a broken rung. And if you have a broken rung, you will not know the foundations that means, and therefore you will not understand the complex mathematics either. So what you want to do is to go back into it, and that's exactly what I did when I started to do well in maths. It was because I was going over the basics once again. You don't want to be stuck in class thinking about what's 7 times 8 without automatically having that come to you. You need to be able to do all the simple mathematics that you learned in year 8, year 9, year 10, all the ones before university, and be able to do that by heart, basically. You don't have to be able to multiply 1,000 numbers to itself. You just need to be able to do simple mathematics mentally in your head quickly. Once you do that, you are going to be able to kind of rewire your brain in a way that makes it so much more receptive to new methods of math. So the way that you can do this would be to use online resources, ask questions, and don't move on until that rung feels rock solid. A little time spent on repairs will obviously make your first climb and your future climb a lot faster and safer as well. Secondly, you want to become a detective. You don't want to just accept the formula as it is. You want to understand why the formula is the way they are. Sometimes the formulas become really difficult to understand. For example, the Navier-Stokes equation here. I'm not going to lie to you, the first time I saw this, I was just like, firstly, why am I doing maths that has no numbers in it? And secondly, what do these even mean? Like, there is so many symbols and so many different things that's happening. But when you break down the actual concept of it, it actually makes a lot of sense. Now, the Navier-Stokes equations is basically a set of partial differential equations in fluid mechanics that describe how fluids like liquids and gases move, accounting for the conservation of mass, momentum, and energy. While it looks really complicated, it's actually just a differential equation that shows F equals to ma, which is something that we learned in literally GCSEs and high school and things like that. Like, it's basically a very simple equation that was just rewritten in a different way because there's so many more components that we're looking at in our day-to-day life right now. When we were looking at it in GCSEs or high school or whatever, we were looking at it only in the 2D scenario and only in a scenario where it is simple because we're only looking at it for the exam, and that's literally the only thing that our goal is going to be, just to know the equation for the exam. But when you go into university and learning about Navier-Stokes equations like these, you're not just learning for the exam anymore. You're actually using it in your day-to-day life, or at least observing it in your day-to-day life, because when I pour out water from this bottle here, I can actually apply the Navier-Stokes equation into this if I'm crazy enough. But it's things like that where you're like, oh, okay, that's why the equation is the way it is. Once you know how it works and what it's for, you can shift from being a passive student into an active detective. The subject then becomes alive and you start to understand a lot more about it, and you become quote unquote more intelligent. Number 3 is to translate the symbols into pictures. Our brains are visual powerhouses. When you see a word problem, don't just see the words, you want to draw it out. And this basically applies more to the applied mathematics. Just to go back into maths again, there's two sides of maths. There's pure mathematics and there's applied mathematics. When it comes to pure mathematics, this is where you learn about all the conceptual bits. You're learning about what the number theorem is. You're learning about what differentiation, integration actually is. You're learning about algebra. You're learning about trigonometry, geometry. You're just learning about the fundamentals of maths itself. It is the basic bricks that yeah, it's like the building blocks that makes maths, while the applied mathematics is how we can actually use it in our day-to-day lives and in the real world. And that comes in chemistry mathematics, biology mathematics. For chemistry mathematics, that could be looking at how many atoms can fit inside a compound. When it comes to biology mathematics, we can look at evolution, variation, things like that. We can see how many daffodils are present in a certain field by looking at the quadrat of it. There's also the physical maths, there's also mechanics, there's also machine learning, there's so many other things that you can use maths in your real world scenarios. With this, when you are able to draw out the scenarios for applied mathematics especially, and visualize what is happening, it actually makes maths a lot more simple and a lot more making of sense. Because when I look at my bottle and I see how the water flows out when I tip the water out of the bottle, I can really visualize that. And when I visualize that and look at the conceptual bits on a piece of paper, my brain will link the two and two together, and it makes just a lot more sense. Like, I don't know what it is, but it just makes a lot more sense when you visualize it. So make sure you do that. Train your brain into understanding mathematical concepts in visual format. If you don't have any ways of doing that, ask ChatGPT, ask Gemini, watch YouTube videos on turning it into a visual that you can use on a day-to-day basis, whatever it is, I don't care. Now, the next thing is also training your brain with consistency, and that's tip number 4. You can't get strong by lifting huge weights once a month. You can't get good at maths by saying, okay, I'm going to do complex maths. I'm going to do the engineering maths with Laplace transform and Fourier series and whatever it is that you want, and the Maclaurin series or whatever, and just say, I'm going to do that this month and that's it. I'm going to be smart in maths. It doesn't work that way. When it comes to maths, short, consistent practice is a lot more effective rather than just studying in one burst and cramming and that's it. You really need to practice, practice, practice when it comes to maths. And again, it's super lucky that maths is the way they are because, yes, it is confusing, but because there's so many other not types of maths, but because there's all the other maths in the world connect to each other, like I said before, Singaporean maths, UK maths, Indonesian maths, US maths, Australian maths, they're all the same type of maths. That means you have an unlimited resource of questions that you can work through in order to understand and practice more. That's literally it. Like, just practice from all the resources that you have in this world. Just imagine once upon a time, these mathematicians, if they did want to get to the level that the previous mathematicians were in, they would have to do so much practice by doing math in the library. You don't have to do that anymore because you literally have the entire world's library at your fingertips, in your phone, in your computer. So just do as much as you can and you'll get better at it eventually. Like, literally, that's just it. And this is important because you're not just studying, you're actually training your brain to recognize patterns and solve problems intuitively, which actually will help you a lot as you go through in other types of subjects as well. Because of this, I'm able to literally go into any exam for any subject that I'm learning and find the patterns in the question and be able to answer them in a very accurate way without thinking too much. And that's also one of the reasons why chemical engineering wasn't actually too big of a problem for me. Like, a lot of people say that chemical engineering is one of the hardest degrees. I would say it's not. Firstly, I loved it. And secondly, I just understood very well what the fundamentals of maths were, which allowed me to understand how the rest of the world works. I know that sounds insane, but that's literally what maths does to you. So, the story of maths is our story. We can't escape it. We can't do anything else about it. It is the tale of our relentless drive to find patterns. That's just the way our brain works. You want to solve problems, you want to understand the universe. It is a language that allows us to describe everything from the dance of subatomic particles to the grand waltz of the galaxies. It's not an easy language, but it is one that is worth learning. Because when you learn to read the code, you don't just get better at solving problems, you actually get better at finding a deeper and more profound appreciation for the intricate, elegant, and beautiful structure of reality itself. So yeah, That was a lot. That was a very interesting topic for me to kind of make and talk about with you guys. I hope that you found that somewhat interesting and you find a whole new perspective on maths after this. I hope you love maths as much as I do right now. And yeah, if you have any questions on that, let me know in the comments below. I'll try to answer it as best as I can. And thank you for watching. If you think your friends will find this interesting as well, don't forget to share it to them and see you in the next video. All the best. Bye.